Yo, Lun Gang, what you telling me? Uh, yeah, mate. Bruh, Frank the Tank is back. What you saying, Frank? Hey, yo, Frank smashed year 12, you know. Hey, yo, Frank, tell everyone what you got in your year 12 exams. Yo, Ian, what's up? Finnica, what you saying? Sakir, what you saying? Let's hear it, Frank. IC wants to know. Man like Carl, what you saying? Rohan, what's up? Rayhan, what's up, Lun Gang? Bye-bye, Yusuf. What do you mean? Bro, we haven't even started. Walkthrough, what you saying? Static, what's up? Sakir, I'm doing good, man. Doing good. Just waking up. I uploaded a video to Instagram yesterday and it's blowing up. And I'm trying to keep up with the comments, but I just can't. I'm trying my best. But, because usually what I do is I respond to people's comments on Instagram in the morning when I'm on the train, but at the moment it's just moving crazy. Finnica, Cotillier goes to my school and was in your class. Was he? Cotillier is such a legend. Oh yeah, Yusuf, you're in year 6. Hey, you can still chill here, Yusuf. Remember, I taught a 10-year-old to get an A star in maths. Wait, have I even seen you guys yet? I don't even think I saw you guys in that time, right? The last time I saw you guys was on Wednesday. Hey, yo, guys, I don't know if you know, but my student, Cotillier, who's 10 years old, got an A star in maths. So if my student Cotillier got an A star in maths, all of you guys can get at least an A. Really, you should all be getting an A star. Look at Frank's results at the end of year 12. Come on. All you guys need to do is just listen to my ways and you've got this, man. Yo, Tazib, what are you saying? Correct. Hey, yo, Frank is correct. Hey, yo, Icy, I got you, man. Bro used to flex on us in class. Yeah, Cotillier can flex because bro is just too good. 7's back. Hey, yo, Zakir, man, I'm telling you, it's crazy, right? But you just got to keep working hard. It's all about what you see at the end of that in a year's time, innit? It's what you see in that envelope. Come on, Carl. So, for the past, 4 lessons, guys, I've introduced you to a bit of year 13 pure. Now I'm going to show you guys a bit of year 13 mechanics and stats. So this year, I think I focus on mechanics this week, sorry. And next week, I'm going to show you guys a bit of stats. So just to give you guys an all-round feel for what like year 13 looks like. Yo, Ishak, what are you saying? So this part of mechanics I'm going to show you guys is actually really fun. If you guys know how to deal with triangles, then you'll be all right. Yeah, I think you guys know your SOHCAHTOA, hopefully. So if you know your SOHCAHTOA, you're chilling, innit? All right, so it's known as resolving forces. So we do not like working with forces acting in many directions. We like to see how forces are pulling objects parallel and perpendicular to the plane they are resting. So for example, guys, if you have a ball, if that ball is being pulled this way, we don't like that. Yeah, we're like, what does that even mean? Yeah, so what we're going to start doing is saying, look, if you're pulling, what is this? This would be northeast, right? So that's northeast. Instead of looking at how that object is being pulled northeast, what we would be more interested in is how is it being pulled east and how is it being pulled north? Individually, yeah? So we don't like northeast. We like east and north separately, yeah? So that's what we're basically looking at today, yeah? So check this out, Yozan. We have 2 forces, 5 newtons, 6 newtons acting on a particle P down here. What is the magnitude and direction of the resultant force on the particle? So just in general, guys, if you have a ball, this is a ball, and think of these as ropes, yeah? Both of these are ropes. So one of the ropes is pulling up and one of the ropes is pulling sideways. If you pull them simultaneously, like this, if you guys use north, east, south, west to help tell me, which way do you expect that ball to travel? In which direction would you think that that ball is going to travel if you're going to pull it up, yeah, and you're going to pull it to the right? So you're pulling up and right, up and right. Think of that 5 newtons and 6 newtons as a rope, and you're pulling it like this. Which direction is it going to go? Yes, northeast. Yeah, it's going to go somewhere here in the middle. Yeah, and that's very common, right? So, you know, forces, we call this the resultant force. We call this the resultant force. Now, a resultant force, it's in the name, yeah? Thanks, Swara. Resultant force meaning the result of applying many forces to an object. Ted, you're violent in use class. Yo. So, we would expect, yeah, it to be about in the middle, but because 6 newtons is stronger, we'd expect it to be maybe a little bit more closer to the 6 newtons, yeah? Now, how do we find this resultant force? It's very simple. You guys actually did it at in year 12 as well. What's good, G1? And the way we do that is we write each force in vector form. And you guys are talking about Pythagoras, yes? Now we have to, because I'm going to give you guys questions where there's loads of forces everywhere and you can't just do Pythagoras straight away. What we need to do is we need to get used to, writing things in vector form. So 5 newtons up in 2 dimensions, what would that be in vector form? Now the resultant force we call R, underlined. My year 12s will definitely remember this when we did this in mechanics. So if you're doing 5 newtons up, what would that look like? Frank knows. Rayhan, nearly there. So 5, 0 would be 5 in the x-axis, right? So we want 5 in the y. Interesting, exactly. So remember, so 5 in the y, so it's the y coordinate, right? Good. So 0 in the x and 5 on the y. And then the 6 newtons, what would that look like? What would you do with the 6? Good. This one's 6, 0. Yeah, Ruwe. 6, 0. Yeah. Now, what do you do to these forces to find the resultant force? See if you guys remember from year 12. It's all exactly the same in year 13, really. What do we always do to the forces to find the resultant force? Not subtract. So subtract would be accounted for within the vector. Yeah? What do you mean Neil 0, chat 1, Ted? What are you talking about? Yo, are you going back to the cram course? Okay, we add them. So this is back to year 12, guys. The resultant force, maybe you want to write this down. The resultant force is always equal to the sum of the forces in vector form. So can you see I'm underlining the letters? I'm indicating that things are in vector form. Yeah? So we always sum everything in vector form. Now when you add the top and the bottom, you get 6 on the top and 5 on the bottom. And that's in newtons, and that's in vector form. Now I want the magnitude, and you guys were saying this before. To find the magnitude, you do Pythagoras. Magnitude meaning the size. Yeah, if you guys look at my diagram, all you guys have told me is that you're going 6. Well, that's terrible. All you guys have told me is that you're going 6 to the right and 5 up to make this triangle of forces. Now the magnitude is the size of that. We call that modulus R. We just do root 6 squared plus 5 squared. Let's keep it exact. What is that? What's 36 plus 25? Like 61 or something? It's either 51 or 61. I don't want to think right now. We'll keep it exact. Yeah? Now, what's the direction? Now, who remembers from year 12 how you work out direction? So look at this triangle here. How do we indicate the direction? So we can't say northeast. That was just so that you guys would indicate to me that you know the general direction. The angle. Good. So we need to work out the angle. Should we work out, so here's my 90 degrees. Should we work out the bottom angle theta or this top angle alpha? Which one would make the most sense? So IC and Omar are indicating theta. Feta cheese and that. Ayan, good. Ruay, the feta cheese. So we should be working out theta, mate. So, to work out theta, guys, how would you do that? Theta, mate. How would you work out theta in this case? Emma, nice. So inverse tan of 5/6. Can you guys type that in the calculator? I haven't even got out my calculator, so you guys can help me out. 1 dp is probably fine. Yo, Abdullah, what are you saying, OG? Static got 39.8. Ted got 24 degrees. Wait, you talking about the weather outside? Nah, this guy. Yo, Ted, 39.8 degrees. Okay, so, nah, Ted's just trolling. So, so what you say, guys, is this angle is 39.8 degrees. All you need to do is you're saying it's above the horizontal. Yeah, you're rotating above the horizontal. So we just say above the positive horizontal. Yeah, you can say the positive x-axis. It's up to you which one you want to say. Yeah, so remember, this is the positive x-axis and this is the negative x-axis. Yeah, because sometimes we'll have forces pointing this way. So we have to say if it's above or below the negative x-axis here. Yeah. All right, nice. So this is an introduction, and this is what you can expect to see in year 13. Now, we have 3 forces, 10, 5, and 6, all acting in random directions. Now, it's not looking good because even from here, guys, like if I asked you to do northwest, east, south, I said that in such a random order, you wouldn't really know where that resultant force is going, right? It's too awkward. And here is a classic case of where we need to... Was that my LinkedIn? Oh yeah, that was my LinkedIn. I don't know if you guys heard that notification sound. LinkedIn's been popping recently. So here, yeah, we need to resolve everything exactly into their components. So it's left, right, up, down. Let's do the easy one first. This 5 newtons. We don't know what that is. We don't know how powerful that is when it's acting at 30 degrees. So we need to resolve it into its components. Now, when you guys tell me the components, can you tell me the horizontal first and then the vertical? So we're going to turn into a triangle. So you can think of this as like going northeast. So we're moving east, the horizontal, and then we're going to go north. Now you think of this 5 newtons as like the hypotenuse, or just 5. Yeah? So you're thinking about SOHCAHTOA. I want to see what you guys come up with. Remember, this is just easy breaking down. When you resolve the hypotenuse is the easiest one. So I'll remind you guys how it looks. I just want to see how you guys write it down at first. Physics is clutch for this. For sure, like the mechanics side we'll do here in maths will help with the mechanical side of physics. So in this case, this is like general. Let me show you guys what it looks like in general. Now, when we resolve a triangle where you have theta and the hypotenuse and you want the components, the adjacent side, remember this is the adjacent side, the adjacent and the hypotenuse will always be cos. This will always be h cos theta. And this is the opposite. That will be sine. It will be h sine theta. Because you're using SOHCAHTOA, aren't you? You're saying, look, sine theta is the opposite, which is what we want, divided by the hypotenuse, which we're given. So you times by h. Yeah, so the opposite will be h sine theta. The adjacent is h cos theta. Yeah. So I want you guys to remember, when you resolve, you are always resolving the hypotenuse. So it will always ever be sine and cos. Yeah. And that's all of year 13 mechanics. If you guys know how to write sine and cos, year 13 mechanics will be super easy. So this horizontal, can you see that's the adjacent side? So it'll be 5 cos 30. And the opposite side will be 5 sine 30. Whoops, 5 sine 30. And that's it. Okay. Now, sine 30 and cos 30, you can actually work out what those are. So sine 30 is a half. Just to save space, this would be 2.5. Cos 30 is root 3 over 2, so this would be 5 root 3 over 2. Yeah? This is a moment's through way because we're not rotating anything. These are just forces pulling. Yeah? We will do, moments is the first thing I teach when we actually start mechanics in December. But can you guys write this force using these numbers in vector form? So it's going to the right by 5 root 3 over 2, and it's going up by 2.5. What would the vector form be there? What would it look like in vector form? Because remember, we want to work out the resultant, right? So what does that look like in vector form? So it's going right and up. So Ishak, that's true about the horizontal. Now you need the vertical in there as well. Nice, Abdullah. Good memory there, son. So Ishak, just combine them now into one, like what Omar and Abdullah have done, and Shristi is about to do. Carl, good. So we're going to the right by 5 root 3 over 2, and we're going up by 2.5. They are both positive, right? Okay. Let's do the same thing with 6 newtons. Here we're going down. You've done it at uni as well. Nice. And right. So we're going down and right. Can you guys tell me what this one's going to be? What is that one going to be? Frank said 6 sine. Keep it in terms of sine and cos. So I don't want the decimal. Carl's just done both. Hey, Carl. We need to make sure we know which one's which, though. So Shristi said that's sine. What do you guys think? Any other answers? Is it sine or cos? Doe's gone with sine. Tiana's gone with sine as well. Good. So, guys, that length is opposite 45. Yeah? So, it'll be 6 sine 45. And then this side is the adjacent. The other one is the adjacent, 6 cos 45. Okay? Now, sine 45 and cos 45 are the same. They're root 2 over 2. So, they're both 3 root 2. Okay? Can you guys tell me what that would be in vector form? So, one's going down and one's going right. So guys, we have to be careful about positives and negatives here. Frank's gone with 3 root 2 and minus 3 root 2. So guys, you have to be careful about positives and negatives here. Carl's done the same, Rayhan's done the same. Good. So this here, guys, is positive because it's going to the right. So we always do the horizontal first, 3 root 2. Yeah. Nice, Rayhan. Emanuela, nice. Khalid, good. Ariana, Shristi, Do, good. And then this one, because it's going down, it's going to be in the negative y direction. So minus 3 root 2. All right, the final one we need to do is this 10 newtons. Now I'm just going to say it's going up first. So it looks like it's going up and then left. Okay. Can you guys tell me what this would be first? What would that side be in that right angled triangle? Because then the other one would just be the other. It's either sine or cos. You guys have to decide that. Rayhan's going with cos. Frank, cos. Okay, everyone agrees it's cos. Good. It's in the adjacent side, right? So it's 10 cos 20. So this is going to be 10 sine 20. Now, sine and cos 20 doesn't have a nice number, so we're just going to leave it like that. Can you guys tell me what that would be in component form then? Right, it's going negative, positive. Do's done the same. Do, you've written cos twice. But otherwise the signs are correct. Ambijit. Remember Ambijit, the top is the x-axis, right? So that one would be first, right? Manuela got the same. Looks like everyone's got the same, but be careful guys. So here we want the x-axis first. So you're looking at left, right first, yeah? So some of you are just reading that 10 cos 20. Just because I told you guys that one first doesn't mean that that's the first one you write down. We always do the x-axis first. Now that's going left, so that's the negative. Nice. And then the 10 cos 20 is going up. All right. Now my question here was, what single force can replace all of these other forces? So here are individual forces. What do we now need to do with them? So now that we've got our individual forces, what do we do with them? Add them, Ella, good. So we don't need to draw anything else. We just need to, we've already resolved them, Carl. So by doing this, we have resolved them, yeah? So we add them up. Now here you just want to put in the calculator, because the 10 sine 20 is orcs, just add them up. Can you guys do it to like 3 significant figures? What does that give you? Where's mine? I should really just get up. Where is it? Boom. Boom. I'll do the bottom one. 2.5 minus 3 root 2 10 cos 20. I'm in radians though, be careful. Always keep your eye. I'm in degrees now. So mine's 7.65. Static got 5.15. Manuel and Rue got the same. Cool. So 5.15. Cool. Newtons. Now this is really important, right? Because, or it's more useful to us, because you guys don't need to erase this, but let me erase it. All of this stuff doesn't tell us anything. This is like, look, I have no idea which way that ball at the center, if there was a ball here, I would have no idea which direction it's moving, right? But with this, I know it's moving 5.5 newtons this way and 7.65 newtons this way. So basically it's moving in this direction. Yeah, which is way more useful information to us, right? So I could basically get rid of all these other forces and say, look, the ball is just moving in that direction. Yeah, which is just more useful to us, and I think we could all agree with that. But it's not difficult, right? Something like this could be worth like 5 marks in the exam. By the way, mechanics always gives tons of marks to students. Something like this, you know, is worth a lot of marks because you're resolving, you're then adding, potentially you could be doing Pythagoras at the end. So yes, it's worth a lot of marks. All right, here's an interesting question where something's unknown. So the diagram shows 3 forces acting on a particle in equilibrium. Find the known force X and the angle theta. Give your answers 2, 3, SF. All right, what do we do first, mate? Trust me, Ted, easy dubs. Mechanics should always be easy dubs. Always. So we resolve. Yeah, so we need to make sure everything is pointing up, down, left, right. Now that 50 newtons is already pointing to the right. Can you guys tell me what this 50 newtons would be in vector form? And then Shristi will do that one after. So can you guys tell me about that 50? Hopefully you guys saw that in the first place. Yeah, 50, 0. So the 80 is to do with the 70 newtons, but here it's just going strictly right, innit? So 50, 0. Nice. Now that 70, we know we need to resolve it, right? So that 70, just thinking at a very basic level, it's pulling southeast. So we need to know how much is it pulling east and how much is it pulling south. Now the triangle doesn't always have to complete, guys. It's just I've made that quite a steep 70 newtons, right? Can you guys tell me what that force would be when you resolve? What would it be? Frank's going with sine. Yo, Abdul. So this one looks to be opposite. Nice, so it's opposite, guys. It's opposite 80. Opposite is always sine. Yeah, 9, good. And the other one would be cos, yeah. So this one is opposite the angle, so it's sine. Yeah, sine. I mean, Lois, you can use cos 10, but let's just use the angle that's given in the question, right? So 70 sine 80. And then this would be 70 cos 80. Can you guys tell me that in vector form now? Will that be in vector form? Be very careful about what's positive and what's negative. What's positive, what's negative. Nine's got 70 cos as positive and negative 70 sine. It's looking good. Ariana as well, good. Nice, guys. So the 70 cos 80 is in the positive x direction. Remember, we always read left to right first, right? Then we're going down, so minus 70 sine 80. Cool. Now the next thing we need to do is this x newtons. Now that is pulling northwest. So you want to pull it up, north, and we want to pull it west. Can you guys tell me what this one would be in terms of x and theta? In terms of x and theta, cheese, mate. Make sure you guys are looking at the correct place. Manuela's got sine. Ishak. Yeah, nice, guys. So this case is sine. Yeah, because we can see it's opposite theta. So x sine theta. Boom. X sine AQM Lun kebab. I could do with a kebab right now, man. We've got x cos. This is the adjacent side. Can you guys tell me what that would be in column form? Rouet has gone with minus x sine. Yeah, Abdul, same. Nice. So this one, guys, is negative, right? So it's going to be minus x sine. And then x cos theta is pointing up. So that's going to be positive. Boom. Now, what's true about all of these forces based on the question? What's true here? Good, Frank. Rouet, good. Rohan, good. So it's in equilibrium. Equilibrium, guys, just means not moving. Well, pause. It can still be moving, but at constant velocity. So I'm not going to say not moving. Moving with constant velocity. Constant velocity also includes moving at 0, right? Constant velocity of 0. But generally speaking, when we're referring to the forces, all the forces sum to 0 when you're in equilibrium. Especially when talking about vector form. When we do when we do F equals ma, I'll make you guys think about it in a different way, which my year 12s already know how I indicate things. I don't do ma equals 0. I think that's a really silly way of doing it. But anyway, from here we can solve. So we need to rearrange for the unknown. So reading the top line, can you see that x, that minus x sine theta is negative? I'm going to take that to the other side. So looking at the horizontal, you get x sine theta is, what is it, 50 plus 70 cos 80. So that's the top line. When you look at the bottom line, can you see the x cos theta is positive already? So I'm going to move over this. Okay, so we get 70 sine 80. Now from here, Do any of you guys know what we could do to find theta? Yes, 9, it means that the acceleration is 0. If all the forces sum to 0, it means the acceleration is 0. So constant velocity, or you could just say that it's just 0. The speed is potentially 0. Sine becomes cos. So you have 2 unknowns and 2 equations. What should you be thinking about? Yes, 9, good. Simultaneous. And Frank, good, you divide. So we know from year 12, guys, that sine divided by cos is tan. So if you divide these two, the x's cancel and you're left with tan. So all you guys need to do in your calculator is do inverse tan of all of this. What does that give you? About, just do it 3SF. This looks weird, I've just written no. And he's got 42. Nice one, Mike. What is that to 3SF? Is it 42.0 or is that what you mean? Or is that a decimal? As in, there'll obviously be a decimal there, but do you mean 42.0? Hey, yo, you guys don't know what 3SF is anymore. What is this? Carl, yeah, you're bad what? What? ¿Qué pasa? Right, now you guys are bugging. 42, okay, so 42.0. If I say 3SF, guys, you need to have 3 numbers there. Okay, the next thing, Ubuntu, what's up? I'll see you later on in our Key Stage 3 stream. Now, the question is from here, guys, how would you work out X? There's different ways you could do this. I'm going to show you guys the professional way. Yes, 9, you can lose a mark. If they ask for 3SF, it's same at GCSE. If they ask for 3SF and you only put 2, you can lose a mark. Now, how do we find X? Now that we know, there's different ways we can do it, but now that we know theta, do any of you guys know what we could do to find X? Nice, Ubuntu. Same. So we could sub it in. So I'm going to show you guys the better way of doing it, but what you guys could do is take theta here, sub it in, and do 70 sine 80 divided by cos answer. Yeah? But, Shrusti, what do you mean by do Sokotoa? So I'm going to show you guys the better way of doing things using the 50, 70 cos 80 and the 70 sine 80. If you look back at the triangle, think about what we've just worked out. We have just worked out the value, of x cos theta. It's 70 sine 80. So that adjacent side is 70 sine 80. So this side here is 70 sine 80. And then the opposite side, this opposite side, if you look at our equation, is 50 plus 70 cos 80. Now that you know these components, how do you work this out? I see, Shrusti. This would be a quicker way of doing it. So not exactly the way, we just do Pythagoras. So guys, to get the value x, all we do is Pythagoras to the components, and this keeps things exact. Whoops. Squared. And when you do that, what do you get about to 3SF? 50, 70 cos 80 squared. Rayhan and static again, the same. Agreed. So 92 point. Hey yo, you guys can't round properly, brev. Did you use 42? Hey yo, it's not looking good. This is why you guys do it the way I tell you, so we don't make mistakes. Rounding errors. Guys, I show you things for a reason, mate. Okay. So that's that one. This kind of question, 7 marks. Yeah, 6, 7 marks in the exam. It's worth a lot. Mechanics is very generous. Yeah, very generous. Zakir, yeah, you were. Now, the next thing, which is very, very, very common at year 13, is slopes. So how do things move on a slope? Now, an object sliding on a slope is subjected to the forces shown in the diagram. Resolve all the forces parallel and perpendicular to the slope to discover if the particle rolls up or down the plane. Now, when we talk about objects on a slope, you have to think about the direction of movement, yeah? So just imagine this is you guys. You're laying on a hill. Now you want to roll down the hill, right? This is where you want to move. So this plane is the direction of movement, yeah? But remember, it's always parallel and perpendicular. We always resolve things in an X and Y axis. So in the last slide, we were looking at this, right? X and Y. All this situation is we're just going to rotate it clockwise. So X is this way and Y is this way. Like that. Yeah. Now we're not going to rotate it back. We're literally just going to work with this rotation in this direction. Yeah. And it's all about the direction of movement. Yeah. So it's all about which way would you be moving wherever you are. So if you're on a slope, you would move this way. So there you go. There's your x-axis and this is your y-axis. Now there's forces which do not follow this, which need to be resolved. Which forces are those? So there's forces on the diagram. Imagine I didn't have this anymore. There's forces on the diagram which do not follow that traditional x and y axis on a slope. Which forces are they? So which forces do not fit that traditional x and y axis on a slope? Ethan, the weight, the 30 newtons. You guys can tell me like what Shrusti's done. The 20 newtons and the 30 newtons. These two forces here do not fit the parallel to the slope and perpendicular to the slope. Like that. Yeah, that's not good. If they do not fit that parallel and perpendicular to the slope, what do you need to do with them? What do you need to do with forces that are not parallel or perpendicular to the slope? You need to resolve them, yeah? And that is it. Now, you're literally doing the exact same thing as you did here. You're just going in the direction of movement and perpendicular. So this 20 newtons, for example, can you see it's pulling, you know, in this direction? All it's doing then is it's pulling it. So you can tell me in terms of parallel and or up and down the slope. So this 20 newtons, so here's down slope or downhill, and this is up slope or uphill. So that 20 newtons, is it pulling the particle up or down the slope? And when you think about things in this way, then you the whole problem becomes super easy. Up the slope, right? Uphill. So it's pulling uphill like this. Yeah, it's pulling uphill. So we just draw an arrow. Now the next thing you have to think about is it pulling out the ground or into the ground? So you're thinking, is that 20 newtons trying to pull it out the ground? Is it trying to pull it off the slope? Or is it trying to pull it into the ground? Out, right? And there you go, you formed your triangle. Okay, nice and simple. There's your right angle. Okay, you guys tell me, what would, when you resolve, what would this be? What would this be? So Frank, sorry, cos, Amber G, Ishat, good, all cos. So guys, you're resolving the 20 newtons, aren't you? So this will be 20 cos 20 degrees, and the other one will be 20 sine 20. Now with these big diagrams, guys, I teach my students to always cross things off, yeah? Okay, cool. Now, remember you guys told me about the 30 newtons, right? That 30 newtons, is it pulling this particle into or out of the ground? Is it pulling it in or out of the ground? Exactly, it's trying to pull it into the ground, isn't it? It's pulling it down. So let's resolve it. It's pulling into the ground this way. Is it trying to pull it down the hill, down the slope, or up the slope? What's the inclination here? Is it trying to pull it down that plane, or is it trying to pull it up that plane? Definitely down. Now, why is that? Say you guys were sitting on a hill, yeah? Say you guys were lying down on a hill. You want to do a roly-poly down the hill, right? That's because your weight wants to roll you down the hill, yeah? So that's just due to gravity. And that's what this force is. It wants to pull you down the hill, down the slope. There's your 90 degrees. Now, the only thing here is that there's an angle missing. And it's very simple to find this angle. I'm going to show you guys this once. Well, I'll show you guys twice if you join my main course. But if this is 30 degrees, here's your right angled triangle. 30, 90, 60, right? In a right angled triangle. Now, this into the ground is 90 degrees. Remember, this whole thing is 90 degrees. So this is 30. So all you guys need to remember is that that angle, when you resolve the weight, is always equal to the angle of the slope. And you don't need to show that in the exam. You just need to remember that they're the same. Yeah? Okay. Very simple. Can you guys tell me which one do I use? I don't know. I do it in random orders, to be honest. What would this one be? That's usually the one I write down first. So you're resolving 30 here. Okay, you guys are going in general with cos, which it is. Because, guys, that's adjacent to 30, right? This is the adjacent side. It's not the opposite. Usually it's easier for you guys to just discover which one's the opposite. The opposite is this. This would be 30 sine 30. And this will be 30 cos 30. Yeah? Okay. Everything is now resolved. Yeah? Now, just so you guys can see things, I'm going to remove this. Everything's pointing down the hill, up the hill, and into or out the ground. Now, the question says, which way does the particle roll? Is it down the hill or up the hill? What would we need to check? How do we know if it's going to roll down, or up? How do we check that? How do we check which way it rolls? So we're looking at up or down the hill. The resultant force, kind of. Nice, Omar. So you're just checking if the downward force is greater than the upward force. That is it. Yeah? So you're just checking values. Down the hill. Don't forget, guys, there's this down the hill versus up the hill. You're just seeing which one's bigger. That is it. Yeah? So, downhill, we are doing 20 newtons and 30 sine 30. Now, when we use these, we generally tick them off. Well, I teach my students to tick them off. What does that give you? I think that's 35 newtons. Just double check that. So that's downhill. Yeah, 35, cool. Now let's go uphill. Now uphill, we only have 20 cos 20. What does that give you? Now that just give me an approximation. And that's done. .8-ish. Arco, yeah. So here we can clearly see that downhill is greater. Yeah. So we're going to say 35 is greater than 18.8, therefore rolls downhill. Simple, right? And then part B is to find the magnitude of the normal reaction. The magnitude is this R. Okay. Now, what has to be true about all the forces pointing out the ground and what's pointing into the ground? What has to be true about those forces pointing out the ground and into the ground? What has to be true about out the ground, Omar, Lois, good? They are equal. Now the reason for that, guys, is that the ball is only staying on the plane. It's not bouncing. If it was bouncing, then there would be an imbalance. But because it's remaining on the hill, it must mean what's pointing out the ground must equal what's pointing in the ground. It's remaining on the surface. So those forces must be balanced. Now out the ground is R and 20 sine 20. That has to equal what's pointing into the ground, 30 cos 30. Then we just rearrange. R is 30 cos 30 minus 20 sine 20, and this rounded. And can you see on my diagram, every force has been ticked off. It means I've used everything. I'm confident that I've not missed anything out. Arco, because it's staying on the ground. So anything pointing up or down, out the ground, into the ground must remain balanced. Unless it was bouncing. If it was bouncing on the hill, it would be different, but that would never happen at A-level maths. We would never talk about that situation. Unless we're doing suvat, but that wouldn't be on a slope. Okay, 19.1 newtons. There we go. Guys, a question like this, 7 marks in an exam, 6-7 marks is worth a lot. Yeah, for part A and B, you're resolving, you're equating, you're comparing, deciding whether something rolls up or down. You know, there's a lot of things going on here, but the maths is not hard. Yeah, so the maths in mechanics, guys, is not hard at all, but they distribute a lot of marks because you're doing a lot of things. Most of the marks come from here. Yeah. Yeah, maybe Frank, maybe something more difficult, introducing friction as well. Yeah. Omar, something like this being 2 marks on a physics paper, I don't know if it would have the same amount of work with 2 marks. Half the question is common sense. No, why? It's good you think that, Carl. So a block of mass 12 kilos is on a slope of angle 40 degrees. It experiences a resistance force of 20 newtons as it slides down. Find the reaction and the acceleration. Okay, so now we're thinking about F equals ma. Now the first thing you should do when you see a question like this is what, guys? What should you be doing? The first thing you should be doing when you see a question like this. Sketch, yeah? Now, I don't know why, I think it's because I'm right-handed. When I do slopes, I always do it like this. Yeah, even though in the last question, QC was pointing the other way. Depends what hand you are, I guess, so. Now we're going to learn how to sketch these things. They're very simple. We're literally drawing a picture very similar to this one. Yeah. So, some dead method. Hey, you get out of here, Frank. Don't make me block you, yeah? So we have a block of mass 12 kg. So we have a block on the hill. Now what forces should you be putting on an object that is resting on a hill? Blocked. Weight, Abdul, good. Now here, guys, 12 kilos, when we put the weight, as you guys know, we should put, as Frank said, 12g. And then we got the weight. The reaction force, the contact force. Now remember, guys, your contact force, R, is always perpendicular to the surface it rests on. So it's not pointing up, it's pointing this way. What you guys are used to in year 12 is you have an object that looks like this. But now we're on an inclined plane. So that reaction force is always perpendicular to the surface, whereas the weight, we say, always points towards the Earth's core. Sounds mad deep, innit? But that's just the way it is. These are small surface approximations of the situation. Okay, so we've got 40 degrees. Okay. Now it experiences a resistance force of 20 newtons as it slides down the slope. So that 20 newtons, which way are you going to point that? Am I playing FPL? What's FPL? Is that football? Fantasy football or something? Okay, so remember the lingo here, guys. So you have uphill, you have downhill, you have outground, and you have into the ground. You guys will get used to the lingo depending on, well, it depends if you learn with me next year, but, so Omar's saying uphill. Nah, I don't do fantasy football. I don't really watch football anymore. But yeah, you guys are right. So think about it, guys. The particle wants to go this way, so the particle is moving this way. Resistance means I'm going to do the opposite of that. So 20 newtons that way. Okay. Now everything's done. I'm going to say that it's rolling down the hill, so it's moving, right? So what we do is we put a double arrow and put A in the direction of movement. Now, what's the first thing we should be always doing before we even start to attempt the question? So what should we still be doing on our diagram? First thing. Resolving. Yeah, so guys, we need to make sure, look over here, everything needs to be pointing in those directions. Into the ground, out the ground, uphill, downhill. There's only one force not doing that, and this will always be the case. Which force is not doing that? Which force is not doing that? The 12G, good, the weight. Guys, the weight will always have to be resolved. And that one is into the ground and down the hill. Okay, this angle is 40 degrees. So just to practice again, guys, what is this force going to be? And yes, I see that would be the case. This would be cos, good. So this would be 12G cos 40, and the other one will be 12G sine 40. We've used this, we don't need any more. Now we can attempt to answer the question, what is the value of R? What's the reaction force? So guys, when you read the diagram, what is the value of R? What is the value of R? I mean, technically you guys have the answer on the screen, but already here. So R, guys, out the ground has to equal what's into the ground. Yeah, so R is simply 12G cos 40. Now remember, guys, for maths, we use 9.8 for the gravity. So can you guys do that? And 2SF. So because gravity we're going to use as 9.8, which is rounded to 2SF. In physics, you guys use 9.81. You do 3SF. We need to round our answer to 2SF. So it would just be a 2-digit number, most likely. Actually, no, it could be 3-digit. Because it's 12 times about 10, isn't it? Oh, but cos 40, we'll do a fraction of that. Carl got 90, mate. Okay, 90 newtons. Cool. So that's 2SF. Now, part B, the acceleration of the block. So we are only using the forces which are left, which are going along the plane, which is only these two, and acceleration. Now, we know it's F equals ma, yeah, because it's accelerating. Now, we know the mass is 12 kg, and we know the acceleration. But what do we write down for F here? Because some of it's going down the plane and some of it's going up the plane. What do we write for F? And this is the same as year 12. So it's the same concept here. How do we do it? What is that value of F? The resultant, and what would it be in terms of numbers in this case? using the orange from my diagram. Not r minus 20. R is pointing out the ground, right? So R does not point in the direction of the acceleration. MD, good. So guys, look. It's rolling down the hill, right? Now, if that particle is rolling down, it must mean that this force of 12g sine 40 is greater than this. It's all about which one's the bigger force. 12g sine 40 must be bigger than 20. So it's all about the net. Yeah, it's all about the net. So if 12g sine 40 is the larger force, yeah, because it's moving down, the net, keeping things positive, will be a subtraction. It will always be a subtraction. 12g sine 40 minus 20, like that. And then finally, we can find A by doing the division. Yeah? Now, if you did it the other way, you'll get a negative A, which is fine. You just make it positive. It just means you did it the wrong way around. Okay, so you type in that in now, and you're going to round again to 2SF. What does that give you? So 12G. 4.6. All right, let's see if everyone agrees with you. Okay, cool, 4.6. Whoops. Easy. Okay, nice. And that's it, guys. That's the foundations to moving on an incline plane. Yeah? Okay. Last question. Donkey is pulling a wooden cart from rest containing vegetables of total mass 200 kilos up a plane inclined at 10 degrees. The rope the donkey is pulling makes an angle of 15 degrees to the slope and pulls with a force of 2,000 newtons. The ground causes a resistance of motion, 1,000 newtons. Find the acceleration of the cart. So our focus here, guys, is on the cart. The donkey is just what's pulling it, yeah? So we're going to draw a diagram. Now remember, guys, we are focusing on the cart. So when we draw it, we're just going to do a particle. Now, in terms of our diagram, do we draw what would be a donkey? Does the donkey matter in this diagram? Do you think we should draw like a donkey in our picture? No. The donkey makes no difference. What part of the donkey is important here, though? It's not the donkey itself. What do you mean? That's crazy. Yo. I mean, we've got the cart on there. Bun that donkey. What part of the donkey is important here, though? If you read, that's relevant to the question. Not the weight, because I don't even know the weight of the donkey. Good, Rohan, the rope. Yes, it's all about the rope. The donkey is pulling using a rope. So guys, we're going to draw a rope with force 2,000 newtons and an angle of 15 degrees. That's what's important to the question, not the donkey itself. Okay, we have the weight, which is 200 G. Okay, your violin. Then you've got the reaction force. Okay. And what else? The resistance to motion. Okay, now which way is that resistance pointing? Which way is that resistance pointing? Downhill, good. Because the donkey's pulling the cart uphill, so the resistance is pointing down the hill of, what is it? 1,000. Cool. All right, to answer the question, to find the acceleration, which is pointing this way, because we're going uphill, what do we need to do first? We need to resolve. I also, this is 10 degrees. All right. So we're going to resolve that 200g like always. So this is going to be 10. So this will be 200g cos 10, same. 200g sine 10. Done. But we also need to do this 2000, yeah? Now that 2000, guys, is it pulling the cart up or down the hill? So this is what you should always be thinking about when resolving forces. Is it pulling up or down the hill? Uphill, good. And then we know it's going to pull out the ground. So there's our triangle. Can you guys tell me what this is going to be? What's that? Sine, good. So 2000 sine 15. And 2000 cos 15. The question wants the acceleration, yeah? So F equals ma. We know the mass is 200. We don't know the acceleration. Can you guys tell me, looking at that diagram, what are we going to use for the net force? So now look carefully at that diagram. What are we going to use for that net force? So you have to look at the direction of acceleration. You need to only be moving in that direction. Carl, sine is pointing out the ground, not in the direction of acceleration. Nyan, you're close. You're just missing one thing. Amberjeet, you're missing one thing. Omar, you're missing one thing. Frank's got it. Good. Guys, look carefully. There's up the hill. There is down the hill. And there's down the hill. Guys, you can't forget about the component of weight here. Yeah? So there's three forces going on here. There's 2000 cos 15. I probably won't have space here. Minus, let's do that again. Minus 200g cos 10. And we are minusing 1000 to equal the mass 200a. So we're just going to divide all of that by 200. What does that give you? Ishak, this is not into the ground. You can see it's pointing down the hill, right? The cos 10 is pointing into the ground, but we're not using the cos 10. We're using the sine 10 that I've indicated in green. You can see it's pointing down the hill. It's not on the hill, but it's a force that's pointing down the hill for the particle. Frank got 2.96. As you can Rayhan in a bracket, but I just subtract both of them. It's just easier to type in. I mean sine 200g. Oh, sorry. Yeah, that's my bad. No, guys, that's my bad. That should say sine 10. That's why. I think that's what Ishak meant. Soz. Yeah, that's what Ishak meant. What does that actually give you, Frank? I don't know if you typed it in properly. And Carl, because I misled you. I misled you, bro. Please forgive. Oh, okay, you typed it in properly. Neil does oopsie. Now that's wild. What is that? So 2.96 is still the right. Wait, no, but Omar got 7.46. Wait. Oh, nah, I screwed it up. Now I need to type it in myself. 2123 cos 15 minus 200 times 9.8 times sine 10 minus 1000 over 200. Okay, yeah. 2.96 meters per second squared. All right. Then find the time it takes to reach a speed of 10. So final question of the day, guys. How would we work out how we find the time it takes to reach a speed of 10? Nyan, it was over here, 200a mass times acceleration. Where I just divided by it on the same line. Suvat. Yes, so here it's just Suvat. So in the question, guys, I say it's moving from rest. We want it to go to a speed of 10. So from rest, 0 to a speed of 10. We have 2.96. Actually, we did use gravity, didn't we? So actually, 2.96 would still be accepted, but let's just say 3.0 for our working. So let's say 3.0 for our working here. And what do we want? We want the time. Okay, what connects all of those? G1, good, V equals U plus AT. Now U is 0, so we can ignore that. So time is just V 10 over 3. And that, what is that, just 3.3 seconds? And that's it. Pretty simple, right, Mike? Pretty simple, Mike. And that is basically an introduction to year 13 mechanics. I don't think it's that bad, right? I think it's when you guys know how to resolve forces, like the whole thing becomes pretty chill. Next lesson, what do I do with you guys? Let me see. Friction and statics. Okay, that'll be cool. So we're going to do friction. I'm going to introduce you guys to friction and how it works. And then next week we'll do some interesting statistics stuff. But in the meantime, guys, remember there's homework that you guys can be carrying on with. And also, if you're interested in my main course starting September, there is a link in the description to click a WhatsApp link and you can speak to my team about that. Yeah. But otherwise, guys, well done. I will see you all on Wednesday, Mike. See you guys. Take care. Hope this was informative for you. See you guys. Have a good one, Mike. Have a good one. See you guys. Peace out. All right, guys. See ya. Nice one, broskies. Peace out.